Hi there, my name's Dave J. Green, and this is another tutorial video for Algebra Tutor. Now, if you haven't got Algebra Tutor yet, then there's a link in the description down below. You can download it, it's a free app, and you can follow along with this tutorial. We're going to go through the topic on expressions. So we're going to look at what sums are and how they're made up of terms. We're going to look at definitions for those words. We're going to do a lot of collecting like terms, some practice with that. That's quite an important skill in algebra. And we're going to meet some particular names that are given to certain types of terms and expressions. So I'm going to click on Go, start the topic, and have a look at the introductory message. So algebra is the language we use to explore much of mathematics, and it really is a lot like a language. Being able to recognise where the separate terms are in an algebraic expression is a bit like being able to recognise where individual words are in a sentence. So if you imagine trying to read a piece of English text with no gaps in it, it's more difficult to see where each word starts and ends, and it could be a little bit confusing. But if we put in the gaps in the correct places, we can recognise where each word starts and finishes, and then it's a lot easier to make sense of. And it's like that with mathematics, with algebra. When we understand where each term starts and finishes within an algebraic expression, then we're better able to understand that expression. It becomes easier to read it. Okay, right, so let's look at how we define a term and how we recognise where those terms start and finish. So multiplication and division glue things together into the same term. Let's talk about that. Multiplication and division glue factors together, or divisors together, into the same term. So I've got here two factors, -3 and y, and I've got my multiplication and division glue, which I'm going to use to glue them together into the same term. So I'm drawing a multiplication sign with my glue, because multiplication glues factors together into the same term. And then I'm going to use that to stick on my y, completely covering that multiplication sign. So remember that if you're multiplying a number by a letter, you just put them next to each other without writing the multiplication sign between them. But that multiplication is gluing those factors together into that same term. So I've got a -3y term there. And similarly, division also glues things together into the same term. So I've got here a 7 that I want to divide by an x. Now remember, in algebra we don't use the division symbol, but we show division using a fraction. However, have you ever noticed that the division symbol looks a lot like a fraction? So I'm going to use the glue here to make a division symbol. So this is my numerator, this is my denominator, there's my fraction line. It looks like a fraction. I'm going to stick my numerator on the top and the denominator on the bottom. And then I've got two things glued together into the same term. 7 divided by x. 7 and the x are stuck together into that same term. And if I put these together, then I'm starting to make a sum. These are not going to glue together. Just the multiplication and division glues factors and divisors together into the same term. So multiplication and division glue things together into the same term. Every plus or minus sign is the start of a new term, and I'll talk a bit more about that in a moment. So in this topic, we're going to look at expressions where there are more than one term. I've done some tutorial videos on the topic on terms where we looked at simplifying just within one term. This topic is going to look at where you've got more than one term in an expression. And so we're going to focus particularly on how to collect like terms, which is a way of simplifying algebraic expressions, something we do quite a lot when we're working with algebra. Some info there. So if you're working with somebody else, it's a good idea to try and explain the new things that you're learning to someone else. That's a good practice for anything that you're learning. And then there's a little bit there, a bit in the introduction about the progress button. If you see the progress button, then you can tap it and move on to the next section. Usually I'd recommend doing a few more questions in that section just to make sure you've really got the idea, but don't spend ages doing stuff that's too easy for you. Okay, let's start the topic then. So this first task then, we've got some information here. It's giving us a definition for the word sum, and either a verb or a noun. So to sum, the verb means to find the total or to add things up. So I'm summing up, that's like a summary. So to add things up, to add and subtract it all together, that means to sum. And a sum is a noun, a list of things that are added together. So something that is being summed together is a sum. So we've got an example here, minus 3x plus 8y minus 14 has 3 terms. So minus 3x term, plus 8y term, and a minus 14 term. So remember, the plus and minus signs are what starts each new term. And the sum, this kind of sum you may have seen before, where you're just adding and subtracting numbers together. Notice that multiplying and dividing, that's not summing, that's something else. But if you just got some numbers that you're adding and subtracting together, that is a sum within an expression. So 9 take away 2 plus 5 take away 4 has got 4 terms, a plus 9 term, a minus 2 term, a plus 5 term, and a minus 4 term. And that particular expression will evaluate or simplify down to just being 8. So if we look at the task, select the sum that has 3 terms. So if I look at this first one, I've got an a term plus plus b squared term, so that's a second term, minus x, so that's a third term, and then plus y, plus starts a new term, that's a fourth term. So that first one's got 4 terms. The second one, I've got minus 5xyz, that's all one term, that's the 5 and the x and the y and the z, the minus 5 are a product, they're being multiplied together. And then I've got a second term plus 60y, the plus there starts a new term, so plus 60. So that one's only got 2 terms. And then this one at the bottom, I've got 9a is the first term, minus then starts a new term, minus x, and then plus 10y is the third term. So that one has 3 terms. So you may notice with these that I'm saying this bottom one has got 3 terms, but there's only 2 plus or minus signs. So we'll look at why that is in a moment. Similarly with the first expression there, that's got 3 plus or minus signs, but I'm saying it's got 4 terms. So we'll look at why that is in this next question, I think. Okay, so every term begins with a plus or minus sign. That's what we need to know. Plus or minus signs are the start of a new term. However, when the sign of a term is positive, and that term is either the only term or it's the first term in the sum, we don't write the plus down. We can still think of it as being there, it's just invisible. So let's consider this sum, 2 take away 5. You might be used to thinking of that minus sign as a thing in and of itself, in between two of the things. But it's going to be far more helpful as you start to do algebra to consider that minus sign as the beginning of a new term. It starts the term minus 5. It's part of the number minus 5. Now, when we write down negative numbers, we always put the negative sign in. This is negative 5. We can see the negative. We know it's a negative number. But we don't always do that with positive numbers. If a positive number is there on its own, or if in this case it's at the beginning of a sum, we often don't write that plus sign down. It might still be there, but it's invisible. We're just left to assume that that is a positive number. However, if we swap these terms over and look at how we do this, the negative sign stays with the 5 because it's part of the number minus 5, but the 2 is no longer the first term in the sum, and so we need now to show its plus sign. So it becomes negative 5 plus 2. We now show that plus sign. It's no longer invisible. So I've got a few other terms as an example here. It is a plus 4 term, a minus 6 term, and a plus 15 term. And so what does this sum come to? Plus 4 take away 6 is minus 2, add 15 is 13. So this comes to plus 13. And it will still come to plus 13, whichever order I put these terms in. Plus 4 plus 15 is going to give me 19. Take away 6 is going to give me plus 13. So however I do that, as long as the plus or the minus sign stays with the term it belongs to, then I can put those terms in any order within that sum. What I can't do is separate that minus sign from the term it belongs to and put it onto a different number. That's going to give me something different now. So positive 6 now, because there's nothing there,
plus 4 will give me 10, take away 15 is going to give me negative 5, so not the positive 13 that it was before. So I mustn't separate those signs from their terms. They belong to the terms they start. And if the first term is positive, then we don't write the plus sign down. It's usually left invisible. We're just left to assume that it's there.
So in this task, it wants us to select the lines that have a term with an invisible plus sign. So I'm looking for ones where the first term in the sum is positive, and so that plus sign isn't shown at the beginning. So this one's got a minus in front of it, so not that one. This one has a minus in front of it. But that's a plus 7a term, there's an invisible plus sign there. That's a plus 6 minus 2x, two terms, and the 6 should have an invisible plus sign. And then this one starts with a plus 4x term, an invisible plus 4x, and then plus 6y minus z. There's three terms in that expression. So there's a visible plus sign there, and here, and here. Okay. So terms in a sum can be written in any order as long as you keep the plus or minus signs with the terms they belong to. Remember, each plus or minus sign is the beginning of a new term. It's got to stay stuck with that term. So I've got four sums here that look kind of similar. They've all got similar looking terms in them, but one of them is an odd one out, and the other three are all the same as each other, just with the terms in a different order. So if I look at all of these, I can see a minus 20, minus 20, minus 20, minus 20. They've all got the same minus 20 term. Now let's look at the plus 8z. This one's still a plus 8z, even though it's got an invisible plus sign. That's got a plus 8z, but this one here has a minus 8z, so I think this one is going to be different from the others, so we can check by looking at the other terms. So a plus 3x term, a plus 3x term, a plus 3x term, invisible plus 3x term, and they've all got a plus 3x term, and a minus 3y, a minus 3y term, a minus 3y, but this one's got a positive 3y, so again this bottom one is different, so this is the odd one out. Okay, some vocabulary then. The coefficient of a term is the number bit at the front of the term. So it's the constant factors within that term. The ones that are written as ordinary numbers. And in a fully simplified term, any number factors will be multiplied together and written at the front of that term. And usually we consider the sign, the plus or minus, as part of the coefficient. The coefficient is kind of at the beginning of the term. Okay, so this question we want to select a coefficient of 2. So select the term with a coefficient of 2. So there's four terms here. I've got a plus 3a term, a minus 2b term, a plus x, and a plus 2y. So if I'm considering the sign as part of the coefficient, then this one is a negative 2 coefficient on a b term. So that's not the same as a 2. And this one is a positive 2, that is the same as a 2. So even though there's no plus sign here, we're thinking, well, that's a number on its own. It's not got a minus sign in front of it, so we're implying that invisible plus sign. That's a plus 2. So this is my term with a coefficient of 2. So all the factors in a term, except for the coefficient in its sign, determine what type of term it is. So this is an important concept for this topic. We're going to be using this idea to recognise the same types of terms in expressions later on and doing something with them. So everything except the coefficient tells you what type of term it is. If you've got two different terms and everything except the coefficient is the same in those terms, it's got the same letters in it, then those are the same type of term. So for example, a minus 3x term and a plus 7x term are both the same type of term. They're both called x terms. But a 3x squared term is different. That's different to the 7x term and the minus 3x term. It's a different type. It's an x squared type. So the x and the x squared are different. They make it different types of terms. So I need to select the x term. So how many of these are x terms? This one's got an x, but it's actually an x squared term. 5 is a constant term. I might talk about that in a minute. Minus 9x is an x term, and then this one again, it's got an x, but this is an x cubed, which is different. That's a different type of term. Okay, so similar idea again, we need to spot the xy squared terms. So look carefully at this now. Which of these terms are xy squared terms? So this is a 2y squared term. This one is a minus 8xy squared term, so that's an xy squared term, we can have that one. This one is an x squared y term, which is different to an xy squared term. Notice the difference there. We want the ones where the y is being squared, not where the x is being squared. So that's got an xy squared, and this one has xy squared. So let's see if it likes that. No, we've made an error, so let's find out what that error is. Right, so did you notice this one, xy squared on the numerator, but in the denominator there's also a z, so that counts. That's not part of the coefficient because that's a letter, not a number at the beginning. So that's actually an xy squared over z term. So that one's different. So just those two are the xy squared terms. So a little bit of vocab here. A constant term is a term that's just a coefficient essentially. It's just got the number and a sign, plus or minus, but there's no letters there. There's no x's or y's or a's or b's or anything like that. It's just the straight number, a constant. So for example, in the sum 3x squared minus 8x plus 5, the plus 5 bit is the constant term. That's the terminology that we use. So in this sum, I need to select the constant term. These ones have all got letters in, so there's 1, 2, 3 terms there. Let's just highlight them so you can see them. 1, 2, 3. But only that first one, the plus 60, is a constant term. Okay, so a bit of practice at spotting like terms then. Two terms are called like terms if they're the same type of term. So they've got to be the same as each other, but they're allowed to have different coefficients. So they can have different sign, different coefficient, different number at the front, but everything else in the term needs to be the same. Same number of x's, same number of y's, same powers on those letters, and so on. So within this expression, there are a few like terms. So let's see if we can spot any of these. So the first one is a plus 4a cubed term. So I'm looking for a cubed terms. So can we see any more a cubed terms? And this one, plus 5a cubed, that's another a cubed. So those are like terms. Those two are the same type of term. Let's see if we've got any more. So I've got an a term there. I can't see any more a terms. I've got a b term here. That's a plus 1b. There's just, remember, we don't write the 1 in front of when we've just got a letter with a 1. That's a constant. That's another b term. So the b and the minus 10b are both b terms. And then we've got another b term, minus 12b there. So all 5 of those aren't like terms, but the a cubes are the same as each other, same type of term as each other. And then you've got minus 12b, minus 10b, and plus b. They're the same type of term as each other. So they're all the like terms that within this sum. And being able to spot those like terms is quite important, as we then need to go and start collecting the like terms, which is something we're going to start looking at soon. Okay. So yeah, quick point. Usually we write the letters in alphabetical order, but not always. We can sometimes be a little bit inconsistent with that in mathematics. The order that the factors are written in doesn't change what type of term it is. So in this example here, I need to select the like terms. I've got a 7ab term there, and I've got a minus 8ba term. Both terms have an a, both terms have a b, and then everything else is just coefficients. So those two terms are like terms, even though the a and the b are written the other way around. It doesn't really matter which way around the a and the b are. I'd say the convention is usually we'd write them in alphabetical order. Okay. Right, and then we get to actually start practicing. So in show me mode, this is going to show you how to simplify these things. So look carefully while you're in show me mode, watch the animation, see how it's done. And then once you get into step check mode and independent mode, you can have a go at doing it yourself. So I've got this one selected at the moment. I'm going to tap simplify and see what happens. So the constant terms, plus 2 and plus 2, they can be collected together to be plus 4. 2 plus 2 is 4. Likewise, the minus 4b plus another b is going to give me minus 3b. And so that first expression simplifies by collecting the like terms down to this one. I've collected the b terms, and I've collected the constant terms. Okay, and then we can do the same idea with this one. Notice those a and b swap round so that it's the same type of term as that one. Those were all a terms, they actually add together to make 0. And these are going to add together to make 0 as well. So this whole expression simplifies down to nothing, to 0. There we go. Okay, and then this is getting into some practice. So again, we'll watch the animations. Two constant terms can be collected together. That means I'm just doing the sum. I'm summing them together. So that's plus 4 plus 12 is 16. And then the y terms can also be summed together. Minus 5y. Minus 5y is going to be minus 10y. Okay, and same idea again. I've got two x terms. 6x plus 14x is going to give me 20x. And an 8y plus a 3y is going to give me 11y. And note we've got an invisible plus sign on that 20x. Okay, and again, same idea here. Constant terms. Usually they're the easiest ones to spot, and just add all the constant terms, or sum all of the constant terms together. Some of them could be negative. And then we've collected 3 different a terms there to get 11a. Okay, this one's got some x cubed terms. It's got 2 different x cubed terms, so we can sum those together, collect those like terms, but no other like terms, so that's all that one's doing. Okay, and then we're into step check mode, so I'm going to have to do these ones myself now. So I'm going to tap simplify, and I've got to enter what I think my simplified expression is. So I can use the paste button here just to get the same expression again. Right, so I'm going to look for a squared terms. I don't have any more of those. So then look for a term. So minus 9a, minus 8a, they're the same kind of term. Minus 9, take away 8 is minus 17. Then plus 4 is a different type of term, that's a constant term. And then minus 14a, so I'm going to do minus 17, take away 14. I think that's going to be minus 31. Let's see if I've summed that together correctly. Yep, it likes that. Okay. Yeah, so in step check mode, it'll do a little checking on each step that you do. Okay, let's try again. So here I can see I've got 2 c terms and I've got 2 constant terms. My constant terms here, plus 15 and minus 15, that's going to give me 0. So I'm just going to be left with my c terms. So a 7c and a 3c will give me 10c. Yeah, and it likes that. Okay. There we go. Okay, and now we're into independent mode. So it's not going to check each step to check if that's correct. I'm just going to do the whole question and then click mark it, and it'll tell me if I've got anything wrong. Again, these are only 1-step questions, so it's not going to make a lot of difference with these ones. But other topics you'll be doing questions where there's a lot more steps. So I've just got the 1x squared term. And then I've got 3 x terms here, so minus an x plus a 7x will give me 6 x's, and then plus another 20 of them will give me 26x. Oh, no it won't. Oh yes it will, I've just forgotten to put on the minus 1, I left the constant term off the end. Now let's see if that's okay, yes, there we go. So it doesn't matter too much if you get things wrong, you just correct it, look for that error, try and spot it, and that's quite good practice. Okay, so let's use the paste button again on this one. So I've got a BA here, let's change that to an AB so I can spot any others. No, can't spot any others. I didn't need to do that then. So I've got 2 A terms. Right, so minus 4A plus 16A, I think that's going to give me a plus 12A. Then I've got a B term and a constant term, they're not going to collect. So I think that will be my answer. There we go. And you can see here the progress button has now shown up, so I'd recommend doing a few more questions just to get the idea, but when you feel confident that you've got the idea of collecting like terms, we can go on to the next section. Let me do a couple more because I think I need a bit of practice. So x terms, I've got 3 of them, so minus 6x and a minus 7x is going to give me minus 13x, plus an 8x, and I think that's going to give me minus 5x. And then I've got a minus 12 and a minus 12, which will give me minus 24. See if that's right. Yep, that's okay. Let's try another one. So I've got some z's here, 3 z terms, a plus 1 and a minus 1 term is going to be 0. But my 3 z terms, I've got a 4, a 5, that's 9, plus a 6 is going to give me 15 z's. There we go. Okay, same again, I've got 3 x terms. So plus 2 take away 3 is going to give me minus 1. Plus 9 is going to give me 8x terms. And then I've got a plus 2 plus 13 is plus 15. There we go. So I think I'm starting to get the idea. As I say, don't spend too long doing things that you're finding easy, but do get the practice that you need. When you feel ready, we can press the progress button and watch the animations and move on to the next section. There we go. So there's Mr. Green firing up his balloon again, starting another journey into some more learning to do with algebra. Okay, and I'll put this next section in another video.